Day 2. So here we have an equation, and some people are like, whoa, that's a big number. Well, it is, but notice that it goes nicely with 30. So what we'll do is just solve equations like we normally do, and we'll divide both sides by 30. So we're left with 3 to the power of x minus 4 equals, now the tens will cancel out, and so now I have to think about, well, can 3 go into 729? Well, 729 we can kind of think about it as prime factorization. So 7 plus 2 is 9. Oh, that's 18. So it adds up to 18. So that I know that a factored is factorable by 3. I do also know that it's factorable by 9 because 9, if it's divisible by 9, there's 2 3's in there, so that's the same kind of thing. So that would factor 3 times 243. I knew there was 4 in there somewhere. So, oh, I also know that one. That one's been it's been popping up with my exponents. That is also a power of 3. That was 3 times 81. And 81 is 9 times 9, which is 2 groups of 3. So this 3 will cancel out with this 3 on the top, and I'm left with 243 as my right-hand side. Simplified. So I know 243, that's this part right here, is a power of 3, which is what I want as a base number. So that would be 3 to the 5th power equals 3 to the x minus 4. So now I can use my property of equality for exponential equations, meaning if the bases are the same, then I can set the exponents to be equal also. So if I add 4 to both sides, x will equal 9 to make that equation true. So now if we kind of go to another one, a more complex one, if we have the cube root of 10, that to the power of 4x set equal to the square root of 10, that to the x plus 30. So even though our numbers are bigger and they look bigger, we can kind of think about it at the same kind of idea. Let's get the same base numbers. I see that they have tens, powers of tens, which I do like. So, but I don't like the format. So that's what's kind of struggling for me to see. So I'll use the exponents. So the third root is 1/3 as an exponent to the power of 4x, because I can deal with those. The square root of 10 would be 10 to the 1/2, and then that would be to the x plus 30. Now, what I'm thinking here is oh, here's where some people make errors. This is our grouping symbol, so I want to think about that right here in this spot before I kind of move on. So 10 to the 1/3 times 4x would be 4/3 x. And when I do my power of 10 here, I want to redo my 0, look like a 6. So I wanted to distribute that multiplied by 1/2. So that would be 1/2 x plus half of 30 is 15. That's kind of nice. It's a smaller number, which is kind of nicer to work with. So now that my bases are the same, I can set my exponents equal. 4/3 x equals 1/2 x plus 15. So I'll subtract 1/2 x from both sides. Now, I need a common denominator here. So that minus 1/2 common denominators of 6, so I can subtract them. So that would be 8/6 would be positive minus 3/6, because 3 times 3, yeah, 3 over 3. So 8 minus 3 is 5/6. X positive equals 15. So now I'll multiply by that reciprocal to cancel them out. And simplifying before I multiply, so 5 goes into 5 once, 5 goes into 15 3 times, so x equals 3 times 6 is 18. So when x is 18, now remember that's coming back up to our original equation. When x is 18, that will make this equation true on both sides. So the same number will happen on both sides. So for our third example, we will solve by graphing. So we're going to solve by graphing 1/2 to the power of x minus 1 equals 7. Now we're going to do this similar to the way we've done this with linear and absolute value. We're going to set the two sides equal to y and y. So y equals 7 and y equals that 1/2 to the power of x minus 1. So here I'm thinking, okay, so I've got the 1/2. It's a decay. Oh, it's a decay. So my graph will kind of angle down and almost level out. Not exactly, but it will continue to get smaller and smaller and closer and closer. Now this minus 1, it's translated to the right one. So we're not going to make us do those because we practiced those already. We're going to use Desmos Graphs. So opening up a Desmos graph, we can set y equals, and we do need a parentheses, 1/2, close, not parentheses, there's close parentheses here. Now, we need to make it into an exponent, so we need to show the keyboard, and if we use this one a to the b power, that'll get us up in there. It's a little tricky because if you press a minus 1, that puts it in the wrong spot. It puts it in the k spot. So I kind of have to get up here and kind of go left once and then minus 1. So you just play around with it and find what works for you. So that would be my first equation. My second equation was y equals 7. And I did notice that my decay is going closer and closer to 0. And once I plot my second one, I notice that I've got my point of intersection. That is the solution to the intersection of those two graphs. So it's negative 1.807, comma 7. Now, we usually don't need that many decimal places, so we usually go to the 2 place values, the second place values. So I'll go back to my problem here, and I graphed it, and I'll kind of think about that graph, and I'll do a little sketch of that graph, but I want to get those numbers down first. So negative 1.81 approximately, comma 7 is that coordinate pair. So let's do a little sketch of our graph so we can remember it. And we've got, it came down, yeah, this way, and then was on that edge before above it. Then we had another line up here at 7, a crossing, and that was our point of intersection here. right there. Now, remember though, we are solving an equation. And what are we solving for? We're solving for x. So notice I didn't circle my coordinate pair as the solution. The solution is the x, which is approximately negative 1.81 is our answer. And that's what I would put on the answer line because that's solving by graphing. The second problem that we'll be doing is by graphing also. So we will graph 3 to the power of x plus 2 equals x plus 1. So we've got two equations here. Y equals 3 to the x plus 2 and y equals x plus 1. So I notice that I have a base of 3. My exponent is, so it's increasing by a times 3. So it's a growth, and a plus 2 would be so thinking about it as a minus and negative 2, so it would be left 2. I hope I said right 1 up here at the graph. I remember that I may have said it the wrong way, but now that I was looking at the plus 1, I was thinking it had to be minus, and it popped into my head. So I noticed on the right-hand side, that's going to be a linear equation, and that's a 45-degree angle over 1, up 1 for our slope, going up positive, and it's translated up. So we'll go back to our equation and or our Desmos graph and graph that. So we need a base of 3, and I can go all the way back and just put a base of 3 because I don't need my parentheses now without that fraction. And x plus 2. So it was increasing, and when I add my x plus 7, now you'll notice when it's x plus 7, there are two solutions. So if it was this x plus 7 on the right-hand side, then we would have two coordinate pairs where they intersect. So for our final answer, we would have 2 x's as our solution, but it's translating only up 1, not 7. So we notice that it's not intersecting at all, both graphs. So that means it's a no solution, meaning that there are no numbers that we can put in for x in our original equation that will make it true. So there are no solutions there. I'm going to draw a quick graph to help me think about this visually. So it increased this way. Ooh, I need to go a little higher. There we go. And that one continued just above the 0, I remembered. And my straight line was right down here, and they never intersected.